Hello, and welcome to Getting Started with Configurable Joins. Today, we will be providing a basic overview of building queries using configurable joins. We will touch on how data is stored within Slate, as well as the basic components of a query, such as the base, exports, filters, joins, and subqueries. By the end of this video, you should be able to build a simple configurable joins query. Before we dive into building queries using configurable joins, we'll spend some time looking at how data is stored in Slate. Understanding the underlying database structure can inform how we choose the base of our query, and which joins we will need to access the desired filters and exports. Data in Slate is stored in tables. These tables can be visualized as spreadsheets. Each table represents a specific type of data, like person data, application data, or form response data. The rows of the table represent the type of object, and the columns of each table represent data points about that object. For example, on the person table, each row represents a person record in a database, and the columns on the table represent fields that store data like reference ID, first name, last name, and birth date. Keeping in mind this basic understanding of what a table represents, we can dive into the relationship between tables. Utilizing multiple tables in a single query is the foundation of configurable joins. There are two types of table relationships in Slate: one-to-one and one-to-many. In a one-to-one relationship, a single row on one table can only relate to a single row on a second table. For example, if we start on the application table and join to the person table, this represents a one-to-one relationship because a single application can only ever belong to a single person record. In a one-to-many relationship, a single row on one table can relate to multiple rows on a second table. To illustrate this, we can take the previous example and reverse it. This time, we'll start on the person table and join to the application table. Because one person record can have many applications, one row on the person table can relate to more than one row on the application table. Other examples of one-to-many relationships are person to schools. A single person can be associated with more than one school, and application to checklist items because an application might have many checklist items. Another thing to consider when thinking about table relationships is that it is possible to change a one-to-many relationship to a one-to-one relationship. One way to do this is by using the concept of rank. Many objects in Slate are given a rank, which represents how relevant that object may be to you. Rank allows users to turn what is inherently a one-to-many relationship into a manageable one-to-one relationship by selecting the most relevant row in the other table, the rank 1 row. Using the same example from earlier, the one-to-many relationship between the person table and the applications table will become a one-to-one relationship if we specify that we would only like to return the data for the rank 1 application. A person can only have one rank 1 application. If we are only concerned with an object of a particular rank, the relationship becomes one-to-one. Now let's take a look at the query builder in Slate. When building a query, the first question we must answer is which base to start on. The base of our query determines what each row will represent. If we start on a base of person, each row on our query will represent a person. If we start on a base of decisions, each row is one decision. A base of materials is one row for each material. One thing to remember is that once a base has been chosen, it cannot be edited. If we start on a person base and later decide our query should return one row per material or one row per application, a new query must be built. For this example, let's choose a base of person. Now that we have chosen a base of person, let's talk through a few components of the query tool. These include filters, exports, subquery filters, subquery exports, and base joins. Exports allow us to choose the information we would like to display in our query. Adding exports for reference ID and student type will display as columns in each row. Filters allow us to limit the rows returned in our query. If we add a filter for student type and select first year, only person records meeting that criteria will be returned. We can also create more complex exports and filters by utilizing subqueries. We will touch more on how to use subqueries later in this video. Joins allow us to access the information stored in different tables. Understanding the type of relationship between the base of our query and the table we want to join to informs where joins should be built. In the Query tool, there are two places where a join can be built: the base of the query or within a subquery. Let's start by talking about base joins. It is important to note that any join built at the base of a query will result in a one-to-one join. When we are building joins at the base between two tables that already have a one-to-one relationship, we don't need to worry about making any extra configurations to account for this, because base joins ensure that information from the join will be accessible without subquery exports or filters. These one-to-one joins are ideal to make at the base of a query. We can see this by adding a base join of person to an application query. Remember, an application can only ever be associated with a single person. From the filter section of the query, we can see that person filters like reference ID and birth date are immediately available to us. The same is true for exports. If the relationship between the base of the query and the table being joined to is one-to-many, creating a base join will flatten the relationship to one-to-one. We need to specify exactly which row we're joining to on the other table, so that we pinpoint the exact data we are looking for. For this example, let's start with a query on the Applications table and join to Decisions at the base. This join pulls back information, but because we know an application can have many decisions, are we pulling back the right information? We'll need to specify which decision we are looking for by configuring our base join. Let's try again by joining to rank one decision instead. An application can only have one rank 1 decision, so when we tell the query that we only want those decisions, we are sure we are getting the right information. When we join at the base using rank, we can be sure that the results that return are consistent. Another example is a query built on the person base that joins at the base to the rank 1 application, effectively creating a one-to-one relationship. Configure this join by joining to Application by rank, selecting Continue, and adding a 1 in the space for rank. Creating a join at the base of a query will never change the rows returned by a query. A join at the base will only give us access to information on other related tables. The only way to limit the rows returned by a query is to add filters in the filter section. A subquery is, as the name implies, a query within a query. Subqueries allow us to create more complicated exports and filters by asking more complicated questions within our query. Subqueries also allow us to create joins between tables with one-to-many relationships without flattening the relationship. Let's start by looking at subquery filters. When it is necessary to add filters that rely on a one-to-many relationship between tables, we will need to use subquery filters. Maybe we want to look through all decisions on an application record and filter for a particular one, or we want to look through all applications on a person record and return any with a student type of transfer. These situations call for subquery filters and exports. Let's take a look at how this is accomplished. For subquery filters, navigate to the Subquery Filter button. Once inside the subquery filter, we can see that we have what looks like another query window. We can add exports, filters, and joins just like a regular query. However, because this is a subquery filter, we also see a drop-down for aggregate. The aggregate represents the type of question we want to ask in our subquery filter. We can leave it as the default of exists for now, since that will return rows only when the data specified in our subquery filter exists. From here, we are able to join from the Applications table to the Decisions table. Specify a decision code of AD and return any application records that contain an admit decision. By filtering for only these type of decisions, we have limited the amount of rows in our query to any application that has an admit decision. We can further limit the rows of our query by choosing a filter of status. From here, we can filter to only decisions that are confirmed, decisions that have been released, or decisions that have been received. Let's choose Received. We can also use subqueries and exports to display the data we need within the query we are building. Let's copy and paste our subquery filter for decision status and add it to a subquery export. From our subquery, use the keyboard to copy by hitting Ctrl-C or Command-C on a Mac. Then open another subquery, either a filter or export, and hit Ctrl-V or Command-V. We've now copied our subquery. An added benefit of using a subquery export is the ability to configure the output of our export. Perhaps we would like to count how many applications a person has. Choosing an output of count allows for this. To do this, let's use our query with a base of person. First, let's filter the results of our query to only include person records that have applications. From a subquery filter, join to applications. Make sure the aggregate is set to exists. Name the filter Application Exists and hit Save. We can see how the matching rows has dropped to only those person records that have an application. Now, we'll select the Subquery Export button and copy our join to applications. From the Output drop-down, we'll select Aggregate, then Count. When we preview the results, we can see a count of how many applications each of these person records has. Joins within subqueries are only available within the subquery itself. If we would like to use that join elsewhere in the query, we'll need to rebuild the join in additional subqueries or use the copy and paste function. Thank you for joining us for getting started with configurable joins. As you can see, configurable joins allow for much more freedom when querying. As you build your own queries using configurable joins, be sure to check out additional resources for querying in the knowledge base and community forums. We look forward to interacting with you there.